So now we are on to chapter 4 here, driving elements. So now we have the ability to detect traffic signals and emergency vehicles and so on. Now we have to start driving on this road with other cars. What kinds of categories of problems do we have to deal with now? We have the problem of visibility, being in the blind spots of other vehicles. How do we brake and stop appropriately? How do I change lanes? How do I deal with parked vehicles, or how do I even know it's a parked vehicle? How do I plan a trajectory? How do I maintain the proper spacing amongst other vehicles? How do I predict the vehicle behavior of others on the road? And how do I read vehicle signals? And then how do vehicles perhaps talk to each other? All right, so first is visibility. How do I make sure that I'm seeing everything I need to see in order to make the right driving decisions? This is all about obstruction of your vision. How do I improve visibility of a traffic signal or intersection? I assess the current visibility of a traffic signal, and then I move my vehicle to a position with better visibility. So if I'm behind that truck, can I inch over to the left side of my lane and see the signal better? What about an occluded object? How to respond to a partially occluded object? My sensors are telling me that there's an object, but it's only seeing a portion of that object, so I'm not certain that I have identified the object correctly. I need to detect that image, determine the location of the object in the image, characteristics of the object, and determine whether it's partially occluded, and create a driving strategy based on that occlusion. The next one is on information gain again. How to determine the benefits of information gain versus the risk of taking an active sensing action. Yes, I could get better information if I was in the other lane, but now I might be farther away from the right turn that I'm going to be making in a couple of blocks. What about at an intersection? How do I handle sensor occlusions there? Identify a trajectory that will cross the intersection at a first point and then a second point outside of the range of the sensors for a hypothetical vehicle to be approaching me from. So I'm trying to guess if somebody else is coming from a blind area and determine the amount of time it would take them to come from that area and travel that distance compared to a threshold time, and use that to complete my crossing. The second to the last one is the sun. How do I maneuver due to a sun condition blind spot? Determine an impact of the sun condition and maneuver by accounting for that condition. The bottom one here, identify a blind spot. How do I determine a sensor blind spot? Once again, going back to our map data, we use the map data to compare with our current sensor data and determine what is out of view of our current sensor, but that our map data might be able to help us with. That is your visibility set of patents. There are some pictures of trees blocking signals, so on. All right, what about being in the blind spots of other vehicles? We only have 2 patents in this category, but they're very specific on it. How to avoid the blind spot of another vehicle and how to maneuver through the blind spots. Determine the blind spot and whether I will be entering that blind spot, and determine a controlling factor such as restricting the amount of time in that blind spot. And then what I can do also is identify a set of objects related to the blind spot, predict the future locations of those objects, and determine a control factor based on the threshold period of time in the blind spot. So I'm going through a blind spot, but there are other cars that are going around causing more chaos that I have to deal with also, and that's what that one addresses. All right, and here's your picture of blind spot areas. Same picture both times. Braking and stopping, another important thing to be able to do. 1 second, I need a sip of water. Okay. The first is a method for a specific type of braking, a steering-based scrub braking maneuver. Make a determination that I need to reduce my speed and what my braking range is, and provide instructions to turn a pair of wheels away from parallel to reduce my speed. So that's your movie style turning and sliding, perhaps. How about assessing the likelihood of a collision and whether or not I need to brake? Create a coordinate system, generate an occupancy grid, so it's an other vehicle occupancy grid in the vicinity of my vehicle, and apply a filter to determine my confidence level that an object is on a collision trajectory. How to stop based on this type of a context? Receive a request from a passenger to stop the vehicle. And from that, I need to determine the current stage of the route that I'm on based on the distance from the pickup location or from the destination. And I stop the vehicle in the current stage, wherever that might be. So I guess this is one where the customer just decides they've had enough of this ride and they want to get off. There's no specific braking methodology going on here. It's a request from the customer. How to make split decisions. This is very algorithm-y. Receive input values regarding attributes of another vehicle, including variance values and uncertainty values. Provide a plurality of outcomes associated with split decisions based on the input value being above or below a threshold. Determine the split decision likelihood of an outcome. So there's a patent on how to be prepared for anything. The last one here, stopping, how to pull a vehicle over. Select a region of a road and based on speed and region distance, determine a braking profile and a stopping region. So depending how far or how close, I will have a different way of stopping. All right, there's your scrub braking drawing, collision prediction system. What's this one? Context-aware stopping. This is where we drop the passenger off before they get where they told us they wanted to go. Here's a distribution tree, pulling over a vehicle instructions. And now we go to lane changes. How do I change lanes? One is the active sensing again. Determine the information improvement value to an active sensing action, such as changing lanes. And in this case, I do change the lane. The other thing I need to do when changing lane is provide a notification. And in this case, it's a notification actually to the passenger of the vehicle. Generate a video of the projected trajectory of the vehicle on a map from an elevated virtual camera perspective. Later on, there will be a patent that we will see on, we have this image of changing lanes from the elevated virtual camera perspective. Then when they arrive at their destination, it becomes a different camera perspective to show that you've arrived at your destination. So these all really tied together. Okay, lane changes we've covered. 4.5, parked vehicles. How do I know that the vehicle is actually parked? Well, here is one way to know how. Detect a vehicle having zero velocity, but that's not enough. I also need to know where it is relative to traffic control factors and identify it as parked when it's in a location determined to be a parking spot. And the conditions relating to a parked car have been met, such as not being near a traffic signal. So don't mistake somebody stopped at a red light for a parked vehicle. Lesson learned. All right, trajectory planning. Navigation, stopping locations, and then I even add in here the neural networks that are now popping up in their patents or publications. I guess these are 2019 publications on neural networks here. Excuse me. All right, how to navigate from a first location to a second location, generate a route for the trip using map information, including no-go roadway segments, and navigating and filtering the no-go segments from the map. So we have a map that has certain regions that we can and can't drive in an autonomous mode, and we're filtering out the non-autonomous mode regions, and assigning a cost value to the various local map regions for determining the trip. Hold on one second, I need to take a sip of water. Okay, stopping location. How do I plan my stopping location? Drive along a route based on pre-stored map data, identify a plurality of keep clear regions where I should not stop, but I can drive through, and then with each of those regions have a priority value and generate a speed plan for stopping the vehicle based on those priority values. to identify what that future location is going to be for stopping at. Now we get into a couple of these neural network ones. Now these are publications, not issued patents. The warning there being that they might be much more broadly stated than they will be when they become issued, but nonetheless, probably worth your deeper dive read at some point. How to plan the trajectory of a vehicle using a neural network. First one here, access waypoint data representing previously traveled locations. So we're talking about our map again in a planned trajectory. Obtain a neural network input at each time point, including waypoint data, environmental data, and navigation data to generate an output score indicating an optimal location for our next waypoint in the planned trajectory, and update our waypoint data accordingly. Last one here, obtain training sets that include a set of waypoints and environmental data and navigation data and a target output of a waypoint that represents the target location. So here we're actually just training the system how to use these data sets to generate these output scores from the set of possible locations and determine the output error from using that training set. So one, you have the neural network for doing the strategy. The other, you have how to train that neural network to carry out that strategy better. How to provide an augmented trajectory, detect a condition in which a vehicle is impeded from navigating according to its first trajectory. And here we have a few patterns like this where we send an assistance signal out and we receive a response. Maybe it's automated, maybe there's a human being on the line, it doesn't always say. And that response we're going to send them also our sensor information, and we're going to get a trajectory specification component and a second trajectory that helps us to avoid the detected object impeding our trajectory. Second one here, passenger routing. How do I transport my passenger to an intermediate location for connection to public transportation is what ended up being in this patent. Identify destination on a drivable map with the regions that I can drive in an autonomous mode, and then take the passenger to an intermediate location, not their final destination, where they can find alternative forms of transportation to get the rest of the way. Bottom one here, assertive action. How do I perform an assertive action against another vehicle? Kind of interesting here, it is plan your assertive action and predict the response of the other vehicle. Complete your assertive action by first initiating a movement that would allow you to cancel your assertive action without causing a collision, but still indicating your attempt to complete the action. So it's you're trying to merge into traffic and no one's letting you in and you just kind of inch over the line a little bit, but you can always get out of it if you have to. This is that in the patent form. But then if the second vehicle is taking a particular action that allows you to complete your action, then you complete your action. So here's a good one. Multiple potential trajectories. How do I consolidate multiple trajectories into a single trajectory? Obtain a first path based on the road geometry stored in memory and a second path of a second vehicle in a different lane, and determine the presence of an obstacle in your path, and determine a third path based on the other vehicle's path, plus the fact that you have to get out of your lane. So in other words, something's in your way and a car is coming in the adjacent lane. You have to plan a new trajectory as a result. Last one here, turning. How do I prepare for a turn? Identify a route for making a turn, an area of the lane having the necessary width, and receive information from my perception system to identify an object in the lane and its characteristics and make the turn. So this is a 2018 publication. Once again, this is not specific to those, what did they call it, an unprotected left turn. That is not anything that I saw in this reference. Okay. Neural networks for planning, training that network, augmented trajectory, and testing predictions. Here is my augmented trajectory again. All right, spacing. How close or how far do I need to stay from another vehicle, depending on the situation. So in passing, these patents are not so much about passing the other vehicle as maintaining your spacing during that passing activity. How do I pass another vehicle? Determine a first path trajectory where I will pass the other car, first maximum speed based on a minimum lateral clearance, and ensure that that lateral clearance will meet a minimum and put together my speed plan based on that result. How do I navigate near an object? I use a 3D bounding box, and I decrease the volume of the bounding box, and I navigate based on that decreased volume. How do I maneuver alongside an object? I determine a two-dimensional contour and a set of minimum clearance distances based on a height profile. How do I maintain a safe distance from other vehicles? I get lane information, and once that lane information has become unavailable, I use my sensors to monitor my distance between the vehicle and relative position of the path of neighboring vehicles to estimate my location in the lane. So I'm using other vehicles to guess where the lane is and make sure that I'm still a safe distance from them. Lane position, how do I control my lateral lane position? Identify an object or vehicle approximate to the road and estimate based on the object speed and direction, the positions at which the vehicle will be adjacent to the object, and determine the distance to maintain once again. All right, so here's our way of maintaining a safe distance around an object picture. We have another good picture in here? No. All right, vehicle behavior. How do I figure out what these other cars are doing or going to do, and how do I respond to them? Lane change. How do I predict another vehicle is going to change lanes? Determine the current state of the vehicle and environment and a predicted behavior of the target vehicle based on a number of factors, where one of the predicted factors is changing lanes and a confidence level associated with that. Prediction, how do I anticipate and react to these behaviors? Detect and classify an object along with behavior data of potential actions, and identify any of those actions that would require me to change my control strategy. How do I model the behavior of vehicles? So I receive vehicle data, including location, environment, and classification, identify a behavior of interest based on the vehicle data and map information, and retrieve a behavior model to predict how a commonly classified object will behave based on its classification and movement information. As comparison between the road element and the movement information to confirm the vehicle has performed the vehicle of interest. Some of these get really abstract, but I am looking at a car, what kind of car it is, how it's driving, and guessing what it's going to do next is what I get out of that. Okay, how to determine if a vehicle is stationary. Detect the vehicle that is stationary based on surrounding objects that include a pedestrian or a second vehicle, and determine whether the first vehicle is in a stationary state of being parked or a stationary state of being prevented from moving due to the pedestrian. Vehicle behavior continues. Aggressive drivers, how do I detect them? I estimate a distance between the vehicle and the vehicle exhibiting aggressive driving, and I modify my control strategy to improve my spacing from them. Prediction, how do I predict the vehicle trajectory? Identify two different objects and a set of future trajectories, these objects being cars. Use map information of the environment and contextual information of the second object and a likelihood value of each trajectory based on contextual information to come up with a future trajectory. So once again, some of these, they sound pretty generic, and that's because the solution statements, we try to make them somewhat simple. And if it sounds like a problem or a solution that you are trying to solve, that's where it's worth your while to dig into the, well, we can look at them, to dig into these big, long claims here as a deeper dive of exactly how they are trying to solve these problems and what might be different about your approach. Okay. Vehicle signals. a few here. How do I determine a control strategy based on detection of an object feature such as a brake light? I identify it, and I determine my control strategy based on characteristics of the brake light being on or off, or activated or not activated. How do I identify a vehicle signal? I do an image processing. I receive the image from the vehicle with an image capture device, and I determine by comparison to a pair of images a portion of my image data showing a change in color or brightness, and determine the temporal characteristics that indicate it's a light signal. And finally, I receive an image of a second vehicle and a group of pixels and their color and intensity to determine that it's an active single signal indicator. Networking. So now, what if all the cars could talk to each other? What would that look like? We could alert each other. I threw honking your horn in here. That's the old form of networking. Wireless networking is honking your horn. That's the kind of sense of humor you get when you read patents all day. How do I receive information from other cars? How do I report information to other cars? So I assessed an object in a partial view with a low detection confidence. That's our first one here. I communicate with a remote computer, and I try to find out, is it a different object than I originally thought it was because I have low confidence? And it tells me that I was wrong. And by telling me that I was wrong, it also tells other cars in that area what that object actually is to help them as well. How do I report road event information to other vehicles? I first want to determine the importance of the information, and I have a user interface for validating the information. So the person in the car will have to validate that, yes, that is a pothole in the middle of our lane, and then that information will be sent to other vehicles. Here's the honking the horn one. How do I identify a context for an audible warning? Identify an object in the path of the vehicle and provide an audible signal after a predetermined period of time. How long is it going to take this person to walk across the street? I'm going to have to honk at them. All right, how do I receive information from another vehicle? I receive the information, and I also assign that received information a trust level based on its indicia and trustworthiness. And then how do I report information? How do I assess the validity of map data? I compare a trajectory with map data, and I transmit a signal that the map data is invalid and the map does not include a plausible path consistent with my trajectory, and I am allowed to then update the map with the new truth. Okay, that is our networking. There's cars telling each other what they see. And all right, we are now on to sensing elements. Let me check again if we have any questions.